Hello and welcome again to my channel Be Inspired, the math problem solver tailored for students who are preparing for Lebanese official exams Brevet level. Today I choose another problem related to orthonormal system, which I believe most likely to become in your official exams. So please follow up with me on how to solve such kind of problems. Let's go to the problem itself. In an orthonormal system of axes, x prime o x and y prime o y, consider lines d and d prime of respective equations 2x minus 3y plus 8 equals 0 and 3x plus 2y minus 1 equal to 0. First question, draw d and d prime. So how are we going to go to draw d and d prime? Let's go to the orthonormal system itself. So this is the orthonormal system. We start by taking equation D, 2x minus 3y plus 8 equal to 0. So if we determine 2 points that belongs to D, it's enough for us to draw D by joining these 2 points. How can we do that? Well, let's give a value for y equals 0 and solve for x. So here, if we give y equals 0, x is equal to minus 4. So x equal to minus 4 is the abscissa of this point, and 0 is the ordinate. Let's locate this on the orthonormal system. So this is x minus 4 is here, 1 point which belongs to D. Another point which belongs to D is this time we give x equals 0 and solve for y. So we get y equal 2 and 2/3. Let's plot this on the graph. Okay, this is the second point, 2 and 2/3. So let's join these 2 points together to get line D. So we come up with line D by joining these 2 points. Line D of equation 2x minus 3y plus 8 equal to 0. So let's do the same for equation D prime. D prime is 3x plus 2y minus 1 equal to 0. This time give y equals 0 and solve for x. It will give me y equals 0 and x is equal 1/3. Where is this point located? It's just here. And do the same for the other point, x equals 0, y is equal half, and this is y equal half. Join these 2 points together to get D prime. D prime is of equation 3x plus 2y minus 1 is equal to 0. So these are the 2 straight lines, D and D prime. Okay, good. Let's go to question number 2. Line D and D prime intersects at A. Find graphically the coordinates of point A and then verify your results algebraically. So how are we going to do this? Let's locate A on the graph. So this is A on the graph. A is common to D and D prime, and it looks like the abscissa is minus 1 and the ordinate is 2. Can we verify the results by algebraic method? Okay, yes. A is common to D and D prime. Therefore, the coordinates of A should satisfy both equations. Satisfying both equations means that we're going to solve these 2 equations simultaneously at the same time by taking the system of 2 equations and 2 unknowns using the elimination method. What do I mean by elimination method? Is eliminate one unknown and find the other. One unknown, for example, is y, and find x. So let's do this. If we multiply equation 1 by 2 and equation 2 by 3 and add them together, we eliminate y. We eliminate y and solve for x. X is equal to minus 1. And satisfy minus 1 in the equation here, in one of the equation here, to find y. If we do this, we can get y is equal to 2. Therefore, the coordinates of A is minus 1 and 2, exactly as we have plotted it in a graphical way. So minus 1 abscissa and 2 here is the ordinate. Okay, and this is point A. Okay. Now let's continue with question number 3. Question number 3, let D cuts the abscissa x is at E and line D prime cuts the ordinate x is at F. Let's show this on the graph. Okay, we'll draw again D and D prime, and then we locate E as the intersection of line D with the x-axis, and F is the intersection of D prime with the y-axis. Question is, show that the 4 points A, F, O, E belongs on the same circle where the coordinates of the center and the radius are to be determined. Good. Okay, we already know that angle EOF is equal 90. Is the intersection of x-axis and y-axis, so it's the orthonormal system angle. Therefore, if we pass a circle which EF and O belongs to EF and O, the diameter of this circle should be EF. Okay? Good. Now, if we determine angle EAF equal 90 degrees, then this same circle that passes through EOF, it should also pass through A. Let's draw the circle. We'll draw EF first and draw this circle. Okay. Good. How do we determine this angle 90 degree? Means that EAF is a triangle circumscribed in a semicircle of diameter EF, and triangle EOF is another triangle circumscribed in a semicircle of diameter EF. Let's prove D and D prime are perpendicular. If D and D prime are perpendicular, means that the director coefficients of D times the director coefficients of D prime should be equal to minus 1. So the products of two lines perpendicular, their product should be equal to minus 1. Let's see if really their product is equal to minus 1. Consider equation D. This is equation D here, 2x minus 3y plus 8 equal to 0. To determine the director coefficient, we mean that the director coefficient of this equation is the coefficient of x when, be careful, when we solve for y in terms of x. So therefore, the trick is solve for y in terms of x. Don't say 2 is the coefficient of x is the slope. No, you have to solve for y equal 2 over 3x plus 8 to make it in the form of y equal ax plus b, and a is the slope of this line. So a is equal 2 over 3. Same way we do for line D prime. A prime is equal minus 3 over 2. Is the product of 2 over 3 times minus 3 over 2 equal to minus 1? Yes. So therefore, EA is perpendicular, or EAF is 90 degree, means that D and D prime are perpendicular. Hence, the circle then of diameter EF will pass through AE, AF, and O. Great. How we can determine the center of this circle? The center of this circle simply is the midpoint of EF. Can we find the coordinates, let's say I, for example, of EF? Yes. Okay, what is the coordinate of I? First, let's take the abscissa. The abscissa of F plus the abscissa of E divided by 2 gives me the abscissa of I. So let's solve it here. We can find it as x equal minus 2 is the abscissa of I. So I lies on this straight line. Now, can we determine the ordinate? Yes. Same way, we find out that y, or the ordinate of I, is 1 over 4. So I is situated here exactly. So at a line cuts the x-axis at minus 2, and a line parallel to the x-axis at, and cuts the y-axis at half. Let's see, where is this? This is I. So this is I is here exactly. Okay, can we determine the radius of this point, of this circle? Yes. How we determine the radius of this circle? If we find EF and divided it by 2, we can determine the length of the radius, IF or EI. Okay, take triangle EFO. O at O here, EOF is 90 degree. So let's apply Pythagoras theorem. Pythagoras theorem said EF square plus OF square is equal to OE square. Now what's OF square? OF square is from here. OF is 1 over 2. Square of the OF square is 1 over 4. Same way, OE is minus 4. Square of the OE is 16. Minus 4 times minus 4 is plus 16. So we get that EF is the square root of 65 over 4, or 65 radical 65 over 2. The radius, then simply divide this number by 2, it will give me radical 65 over 4 is the radius. So EI or IF is equal to radical 65 over 4. So we determine the circle, we determine its center, and also its radius. Great. Let's go to question number 4. Find an equation Z of a perpendicular bisector of segment OE. How to draw Z as a perpendicular bisector of OE? We know that OE is minus 4. Or if we're talking length, it should be the absolute value of minus 4 is 4. But since we are using a graphical system, we take the minus 4 and divide it by 2, and the line Z comes here at minus 2, cutting the x-axis at minus 2. Let's draw it. Okay, this is line Z. Line Z is here. Okay. You notice that Z is perpendicular to OF, and the y-axis is also perpendicular to OF. So Z and Y are parallel. So the equation of Z is simply x equal minus 2. Good. Okay, B, verify that Z passes through the midpoint of EF. We want to verify that this line is also cutting EF at its midpoint, means at I. So it passes through the center of this circle. How to prove this? We say in triangle EOF, O is 90, the line Z is parallel to the y-axis, يعني parallel to OF, and cuts EO at its midpoint. Therefore, it should cut EF at its midpoint. So line Z passes through the midpoint of EF, which is I. Okay, thank you guys. That's it. I hope you like my video this time. And please, if you have any such a suggestion, make a comment to encourage me to do some other videos. Do not forget to subscribe and see you on another video. Thank you very much.